Hello, and thank you for listening to this episode of the Night Sky Podcast. My name is Billy Newman.
And I'm Marina Hansen.
And this week we're going to be talking about the things happening above us in the sky for the, 22nd of April to almost the end of April, right? That's like the week that we're in now. I was looking at some of the events that were going on, and then we're kind of going to dig into a couple things about the planets that you can see right now. It'll be fun to talk about. It's going to be cool. There's a lot of stuff going on right now, and we've done a lot this last week too.
Yeah, we've done some observational things.
Yeah, which is definitely the way to go. We got to do more observation stuff as much as we can. This is the season for us that becomes the most possible, especially here in Oregon and in the Willamette Valley in the winter.
Definitely.
And this winter, I think it's been an El Nino year, they say, but there's been some nice days too.
There's been some nice days.
A lot of waves of clouds.
It's pretty stormy now, as a matter of fact.
Most of November, December, January, February, and I'd say March are all months where there's really consistent cloud cover, and there's a very slim chance that you'll be able to have a continued amount of good observational viewing nights for stars or for astronomical events that are going on. Like in the mornings, we rarely, I think, had a day to do observations of the 5 planets being up at the beginning of February.
Yeah, there really wasn't a good opportunity for it here. There were a lot of clouds.
There were a lot of clouds. Yeah. And so we were able to see, a few things a couple times, but I think, this is the time of year for us in the middle of April as the weather starts to break for us, as we kind of start moving into May, and even really still at the end of April and into May, there's a good chance that we're going to have a lot of days that are a little bit mixed. Even right now, we're dealing with a little bit of mixed weather, whereas this afternoon, it was nice and sunny.
Yeah.
We have a thunderstorm passing through.
Yeah, so, lightning earlier.
Yeah, it was cool. So there's a lot of change going on atmospherically, weather-wise for us, but it's finally the time of year where we're going to get some good observation nights. And it's a lot of fun too, because it starts getting dry enough and warm enough and, nice enough out at night that we can jump out and do a couple things that take a little bit more time outside. What I want to do really bad is I want to get out to a spot that has some dark sky, like a place that's pretty far away from a lot of civilization stuff, and we should try a few of the things that we did the other night, and we should do some stuff with our cameras, like photographically. We should try and take some pictures of the Milky Way or some wider expanses of a place. I think that'd be really cool.
I'd really like to do that.
Yeah, we should try and do some of those photographs that we see of like that rich Milky Way look that we can pick up. It'd be a lot of fun to try, especially in a spot that has like a really good dark sky. Up on the Steens is great, or just really anywhere out in Eastern Oregon. You can get a really good spot that's away from town, and that it could be 100 miles away from another small town. That's the next place that you can see light from. Yeah,
I think that some Eastern Oregon observations would be really good.
Yeah, it'd be fun to try. It'd be cool, especially right now, just because Jupiter is so bright and so high, and then also the summer with Mars being so bright. It's gonna be pretty neat. But you can see a shadow cast. We talked about it last week. You can see a shadow cast by those big planets, and it's really cool that you can tell. But you can kind of see a cast shadow on the ground if it's really dark out, or you can kind of make your way, or you can see by starlight is sort of what you're noticing. So it's pretty strange to see, but Jupiter is real bright right now. And it was cool to see. There's a lot of planet stuff going on. That's probably what we're going to talk about through the podcast is Mercury. Just the other day hit its greatest elongation. We had talked about that when we were talking about Mercury making its transit into the evening sky for the good part of April. And so we've been able to see that in the evenings. I guess a little bit lower than it looks lower than Capella. It's cool because in the evening, we saw it last week when we were driving back from Woodburn. We could look out to the western horizon and you could see Mercury really quite far to the north. I was kind of surprised because in January, and this is sort of that system of the tropics that we have, like Tropic of Capricorn, Tropic of Cancer, and that rock, the rotation that the Earth does to create the different seasons. So in the winter, when we were able to see Mercury at the end of December, I think the beginning of January, I think we were driving back from New Year's from Portland. We could look out and down deep into the southwest, you could see a point of light, and that was Mercury. And then now, as the daylight hours have gotten a lot later, as we have light a lot later into the evening, we're able to look out, and now the ecliptic line is going much further north, and that's why the sun sets much further north, and that's why we have much later evenings or much later sunsets in the evening. And then it goes up to the solstice and then kind of starts to cast back down. But that ecliptic line, that follows that seasonal progression of the sun also. And so that's why right now we have Mercury that's setting really far to the north, kind of, not unusually, but it's just kind of cool to see it for this long and at a position of greatest elongation when it's setting this far to the north. So I think that means it sets pretty late into the evening, but it's cool to see. It's been fun. There's been a couple nights that we've been able to see it pretty well. And I think we'll have maybe another week or so to get that best period of observations, but it's made it to its top point, and then now it's starting to come back down in its cycle, come back down toward the horizon or back down toward the sun.
It's interesting how it cycles like that, or how it makes that ecliptic shape. Yeah,
it's cool. It's interesting how it does that. I don't really understand all of Mercury's movements. There's like a different sets of cycles for each of the planets, like when they're predicted to show up in the evening versus the morning, or like when they're going to be in position for it. Now it's more scientifically determined about based on where their orbits are, but in the past there have been all these little systems and rhythms of Venus has an 8-year cycle of how many times it'll show up this many times in the evening during this period of spring and this period of fall, that sort of a thing.
Right.
And then this many times, in the morning, that sort of thing. It's kind of figured out, or it's got this little like clockwork pattern that it does. And so I think people have been kind of picking up on that for a couple thousand years now, but it's still interesting to see, Mercury make these kind of interesting motions across the sky. But it's cool. We've been able to observe Mercury a few times over the last couple weeks. And then the big one that we've been looking at a lot is Jupiter. We've been checking Jupiter out a lot. It's been a lot because it's cool. It's up in Leo right now, and it's just kind of straight up into the sky. I think it's coming up to its zenith point, which is the highest point in the sky. I think it's called a zenith and a nadir are the two terms. So when you look up at the highest point in the sky, that's the zenith. And when you look at the lowest point in that sphere, that's the nadir.
Oh, interesting. I knew the zenith point. I don't know if I was as familiar with the nadir, though.
I think that's what it is. Is that azimuth? I don't know what an azimuth is, but that's like its progression from the horizon up to the highest point. Is that what that is? The azimuth?
I do not know.
You know what? I don't know either. But we've been looking at Jupiter. It's high up in the sky, and it's cool. We have a pretty simple telescope, but it's cool.
Very simple. It's my telescope from the 90s when I was a little kid.
And we've got it.
We've got it.
And we've got it set up working well enough. Well, first thing we did is we looked at the moon, and we've been looking at the moon in a couple different phases of its cycle also. I think tonight is a full moon.
It is, yeah.
Yeah, and it's going to be over close to Scorpio tonight.
That's cool.
Which will be cool too. It'll be in a couple near a couple planets. We can talk about that in a bit too. But we've been watching the progression of the moon over the last couple of nights. So the first couple of nights that it was in front of or west of Jupiter in the sky, and then as it tracked back close to Jupiter, then right up next to Jupiter just a couple of days ago, and then now past Jupiter, and now over by Spica and into Scorpio now. And it's been cool to kind of watch the progression and then watch the phases of the moon as the moon gets brighter and brighter. And so what we've been trying to do is use this telescope to make observations of the moon each night. And we've been kind of looking at different things that we're able to see. And it's cool how you can examine the moon once you have a telescope or once you have a real close view of it, the different things that you can see.
It was really interesting seeing it in so much detail. There are so many craters on it.
Yeah, so many craters. It's difficult to see them, from Earth, or you can't really refine the detail in that way as like a real spherical object that you're looking at. It's difficult. It sometimes just has that pancaked, circle look to it.
Yeah,
like it's just out there and it exists, but you can't really see it. Yeah, it was cool. So do you remember that first night when we were looking at the moon? You could see out, and then on that meridian line of the day-night line, that's where you could see that contrast in the craters that was there. Yeah, and it was cool because that's where you get the most definition. You can refine the most. But outside of that, like once it gets into what would be high noon on the moon, or what would be just, you know, the really bright part of it, all the shadows are flattened out, and you can't resolve the craters.
There's really no definition in it anymore.
Yeah, it's really strange. And I remember learning that before, that the best time to make observations of the moon is early on, or is early into the crater, or in its crescent period is a good time to take observations of the moon, and then as it kind of builds up. But during a full moon, it ends up being more complicated because it's so bleached out. It's like we're looking straight down at the moon at high noon. Like it would be light here on Earth at high noon. There's no shadows to give any contrast, except for shadows that point straight down that sort of blur the contrast lines that you'd really want to find. So it ends up being, you know, just not as useful like we're looking at when we look at the moon. We get that good contrasted viewing right at that day-night meridian line, wherever the sunset of Earth is from the view of the moon, which would be cool to see because it would last for a whole day. It would just be the Earth at the edge, but there's no atmosphere on the moon, so I guess it wouldn't look too different. But it's cool though to check out the moon, you know, when we're looking at the little craters. And then so as you check it the next night, you see that the phase has progressed, and that you can see and resolve new craters that were now, or that were yesterday, shadowed in the dark side of the moon. Now they've been revealed into light as the phases of the moon kind of progress. So it's cool to kind of watch it move on.
Yeah, it's been really interesting seeing how it changes along the line. It's hard, kind of like you were just saying, though. It's hard to map it out though, or you have to kind of remember where the other ones are because you can't see them. Yeah, it moves along.
We have to kind of place a couple good. Well, it's difficult understanding, first of all, the telescope kind of twisting everything upside down and backward.
Being upside down.
Yeah, and so that's a little interesting to sort of reorient yourself to. But then it's best when you can kind of like map yourself to a couple landmarks on the moon, or a couple shapes. And I think you can do that as you get more used to things, or more used to the full moon. What you can't, you know, if you're looking at it in a phase, you know, when we were looking at, we have this cool little moon globe. And so it's a globe, like a globe of the Earth, like an atlas of the Earth, or, you know, a little globe. You know, it kind of has the resolution of the pieces that are around the moon. It shows like the dark side or the far side of the moon that we don't get to see. And so we were like holding it up and trying to figure out what part we were looking at, or like at what angle, so we could kind of like identify the different pieces or the different landmarks that we were looking at. And it was just really difficult to do. We weren't really sure.
Yeah, there's so many craters on the moon.
Well, yeah.
There's a ton of them. It's hard when you can see a line of them.
We were real accurate into like where we were holding it.
We found the shadows and stuff pretty well, or the...
Yeah, well, it's tough. We should take a look at it, you know, in the next night or two, and we should see some of the things that are revealed now that we can see, and sort of look at the landmarks of like, oh, well, we hadn't hit this part, which we can name and find now. Now that's revealed in the light, but it was, you know, right around this section. So maybe it was these two craters, or, you know, maybe it was this line, that sort of a thing. But it would be kind of fun. We should do more of that though. We should kind of watch the moon's progression. It'd be cool.
Yeah, it's been really cool using the telescope more, or just tracking it and watching it every night. And
it was cool.
Seeing how it moves.
Yeah, I like doing that. We got to do that more. We got to go for.
We got to get a real telescope.
A real telescope. That'll be a little Kickstarter, a GoFundMe page for the Night Sky Podcast. Is support Billy and Marina getting a telescope. It'd be really fun. I'd want to get the camera attachment for that someday, like we've been talking about. Like and put a digital SLR into that so that we can take photographs. Because I think if I've understood right, there's a couple different types of telescopes. So we won't get into a ton of it, but I think we're using a refractor telescope, and then there are reflector telescopes. I think reflector telescopes are the ones that are like the Dobsonian telescopes and the Newtonian telescopes, where the light comes into the barrel and then goes all the way down to the back end of the barrel, the floor, and then bounces back up and then hits an objective lens that focuses the light out to your eye so you can see it.
Yeah.
And so that there's that system of light collection. Because I've heard this before too, is that a telescope's job isn't really to magnify you there as much. Mm-hmm. What it is to help you get a bigger aperture of an eye to collect more light for a dim object so you can get a better resolution of it when you look to it.
Right.
It's kind of interesting how that works, but I've heard that before.
Is that kind of the idea that the Dobsonian ones are based off of, or like how they're designed?
Yeah, it would be really similar to that too. Is that's why they use those really. Ooh, do you hear that thunder?
There's so much thunder.
Whoa.
Wow.
So cool. Gotta shut my noise gate off sometime. It's probably just pure silence. I don't know if we broke the gate, but it's cool. We can hear thunder. I think it clicked in the microphone when the lightning bolt struck, or when I saw the light outside. There's like a little snap, a little interference. Whoa. Shoot. So yeah, we were talking about telescopes. Yeah. So the job of the telescope is to collect as much light as possible, and that allows us to refine or get a better resolution. Kind of like what we were able to do when we looked at Jupiter, finally, like when we get back to looking at Jupiter. We have this little refractor telescope. It's the smallest line of telescope. So I think it's a 3.5 inch.
It's very small.
And I think for refractors, you want to do more than 4 inches.
Okay.
I think is the idea. Yeah, that's when you start getting a better resolution to be satisfying for amateur astronomy stuff. Yeah. That's when it gets more fun. But like we were able to see with ours, given what we're talking about, we could barely make out the bands of Jupiter.
Yeah, that's right.
But it still looked really like a point of light. And you could barely kind of make out that there was some texture, some context that we couldn't really see, like the storm, anything like that. That wasn't visible for us. But we could make out the points of light that were the moons too, which is really the fun thing to observe about Jupiter, at least with the gear that we have, is checking out the moons and their rotation and stuff. And we can see, it's really satisfying because you can see night to night to night how quickly they change.
Oh yeah, it's really interesting.
It is really interesting. Yeah, it's cool. You can see how quick it is, or like you could just kind of tell, like, whoa, yeah, these are really moving around each other.
Yeah.
And it's cool. Yeah, it's fun. It's fun to get to observe. It is really one of the most real things in space that you can just look out to, that you're not really aware is just right out there happening and working around you all the time. And it's cool. You get to kind of, just put a tool up and look at it, and you get to see something that people, I guess, didn't get to see for thousands of years, but it's pretty cool.
Yeah.
I've heard though that you can see like Ganymede or with the naked eye. You can tell that there's like a moon around Jupiter. I had wanted
to bring that up because I was wondering.
I've heard that you can't, but I've heard that there was a thought that Jupiter had like a little brother or like a little companion or something that would be with it wherever it was. So I don't know if that's true, but
I don't know either. I think maybe I've just looked at it in telescope enough now that I'm tricking myself.
Yeah.
But I swear sometimes it looks like there's like a little extra twinkle around it.
It might be.
Or there's like
we should kind of look at how to spot it.
Part. Yeah, we should.
There's lots of things that people can do once they figure out that something's there. Like you can spot Venus in the daytime.
Yeah.
At some periods, but you can spot Venus in the day sometimes. It's really cool. Like you can see the moon in the day, if you know the right spot.
Oh, yeah. You can totally see the moon in the day pretty easily.
Yeah.
It's not that hard to find.
That's easy. But Venus is difficult. And I guess there's some periods that you can do it decently. And it'd be really strange, but it's not something you would know to do or
you have to kind of know to look in the spot.
It's hard. It seems like it'd be hard. But it's cool though that you can do something like that. So, cool. There might be a chance that we could see a real dim 6th, 7th magnitude point of light around Jupiter. That would be like one of the moons or something like that. But they're real dim even in the telescope. Yeah. They're real small points of light. It's really cool though to see. See, they weren't discovered until like 1610. That's the date listed of discovery, or the date of observation with Galileo and his telescope and his observations that he ended up publishing scientifically. But it's cool though that we're able to look out now with our telescope and check stuff out.
It's really cool.
Yeah.
Yeah, it was a lot of fun getting to see Jupiter for the first time. When I was a kid and I used that telescope, I could only find the Earth's moon, really. It's hard setting up a telescope, especially with it being mirrored and upside down.
Yeah, it is a little tough. There's a lot of nicer tools now. Those little rockers that you can use, those dials that kind of slow, that fine tuning where you can kind of roll it on a gimbal across, and you can kind of track an XYZ axis to sort of point yourself out on the grid in a pretty comfortable way.
Yeah.
It's easier now. Or like follow moving things like Jupiter, how it's kind of tracking.
Right.
Or any of the stars, because we're just rolling away from them.
I think we got the chance last year to use a telescope that was set up like that, where it was on a system where you'd adjust it and kind of
we looked at, I think, Jupiter and maybe the moon or something at the time. So. Yeah, it was cool to do that. And it's really comfortable. That
seems like a lot easier of a method.
That's the type of thing I want to get. Yeah, if we're able to pick up a new telescope. There's so many other things. Like that's old technology now. You know, they have like the punch in the code and it will auto track to where it says the object's supposed to be and it'll hold with it. It's kind of interesting. I'm not really that interested in that. I think that's sort of a gimmick or
I like the idea of finding it.
Yeah, I can do that. Yeah. That's what I'm for.
Yeah.
Yeah. But it's cool if you don't want to have to hassle with it too much.
But
it's a fun idea to just kind of set it and have a fun. It's a pain to just kind of float and like sort of float around back and forth to see if you can sweep for just a little point of light that you can tell is Jupiter. It's obvious when you look at Jupiter because it's so much brighter and it's so bright right now. But it's really cool, getting to see the little moons around it. So we were going to talk a little bit about Jupiter, about Jupiter's moons and sort of what you can see and what we were able to see when we were checking out the telescope. So there's the 4 moons that you can see. There's Io, Europa, Ganymede, and Callisto. And those 4 moons make up 99% of the mass of moons around Jupiter. So almost all the weight, almost all the mass, the physical volume of moon around Jupiter is really in those 4 moons. But there are 67 listed moons around Jupiter. And so that means that really there's like 1% of the mass of the moons is spread out between that other set of moons, which is a huge amount. It's a lot, yeah. And so I was kind of looking at that because I was like, well, how does that really work? I mean, there's really 4 moons, right? And then there's a lot of small pieces. And that's really the case. 99%. It's a lot of it that isn't there. And so I guess I was looking into that a little bit. So there was the 4 moons that were discovered in 1610. And then there were all the later moons that were discovered. And I think the first ones were it was like the 1830s and then into like 1904 and then up to 1977, there had been 16 moons total found. So I guess, I don't know, well, like another 12 on top of the 4 that we had. And it was I think it was in 1977 that the Voyager 1 passed by Jupiter and then took a lot of photographs. And that was the point that we had a point of reference, photographs, actual new data that was a lot closer to Jupiter. And so that was what allowed astronomers to map and then find the new moons that they had added to the list after 1977. That's how we moved from 16 moons in the year 1977 and then that bursting up to past 2004 when they added more, and then now to the point where we have 67 moons around Jupiter. It's a lot of extra stuff that's been added over a short period of time. I remember looking at an astronomy book when I was a kid and it said that Jupiter had 16 moons. I was like, whoa. Yeah, well, it's like way more now. That was in the 90s or something that it had been up in the 50s or whatever it was considered at the time. But I didn't realize that they're all really small objects. There's really only a couple of the moons that have a planetary mass, I think is what it would be. But it's that point where there's enough mass for the body to pull itself into a round or a spherical shape. Or a near spherical oblong shape. But a lot of these moons are really just like asteroids, really. Or they're like clumps of stuff. They're things that haven't been able to pull themselves down into round shapes. There's a few objects that are relatively able to, but really not too many. So it's cool. What we can see in the telescope is Io, Europa, Ganymede, and Callisto. Io's the closest, then Europa. So Io's like the volcanic one. Has a huge amount of tidal forces from Jupiter that's keeping the surface of the planet really hot and molten almost. So there's lots of volcanoes and stuff. Then there's Europa. It's very different. It's a lot of water, and I think it's a lot of frozen water. There's thought that the tidal friction from Jupiter, like it affects Io and keeping its surface hot, also keeps the near core or inner surface under the ice hot or warmer with tidal friction from Jupiter. So it's thought that there could be a liquid ocean on Europa that could support life if it was warm enough. But it's kind of an interesting idea. That's where there's a lot of speculation on what kind of things could exist or live in the world or outside of our world and in our solar system. It's kind of cool. So there's Io. Io, then Europa, the ice world. And then there's Ganymede. That's the biggest moon in the solar system. It's huge. It's bigger than Mercury. We were looking up, right?
There are a few that are bigger than Mercury.
Yeah.
I didn't realize how small
Callisto is almost the same size as Mercury.
Yeah,
I think Mercury's bigger, but they're sister sizes.
They're about the same, though. Yeah.
Yeah, I was really surprised to think about that there are moons that are larger than a planet that we can see.
Yeah, and was it Titan from Saturn? It's also bigger.
Is really big. We should look at Saturn because you can see Titan also. I think you can see 5 moons around Saturn.
We should definitely check that.
Yeah, we should definitely do that. It'd be really cool. I think it'd be a lot of fun to try and spot a bunch of stuff around Saturn, and we can see the rings really well. That'd be really fun to do. But yeah, like around Jupiter, there's Ganymede, which is bigger than Mercury. There's Callisto, which is also pretty big. I think bigger than our moon, or about the same size as our moon.
Yeah.
Yeah, it's pretty interesting.
It's pretty close.
It's cool, but and then I think those are the furthest out. So when we looked up at it, you could see it's kind of that thing when you look up, you see like 1, 2, and then a third out on the left side, and then there's 1 far out on the right side, and then the next night you see 2 on the left side and then 2 on the right side, and you go, whoa, how'd that one move so fast? I guess it's Io. I'm not sure yet. We gotta like watch it for a longer time.
I was trying to figure out which one was which as we've been watching them move around.
Some of them have pretty fast periods, yeah. But what we're looking at is the internal, or we're looking at them kind of spinning around each other, and so we had that comment early on. I think from Great Britain. I'm pretty sure is where I was from, but yeah, we had that comment.
Oh yeah, that's right.
He was telling us about the order of the moons, and he was also telling us about this part that we're like the order that we see through the telescope isn't necessarily the order like first to last of the moon, because they're they're in orbit, they're in an elliptical orbit around Jupiter, but they're kind of at a flat plane to us, so we see them kind of pass back behind Jupiter and then out in front of Jupiter, and so their order could be kind of scattered in the observation when we look out, or their order inner to outer orbit can be scattered from our perspective, looking 2-dimensionally out into a telescope at it. But it's cool. It's really fun to observe. And then you kind of get a better understanding, or I bet just like looking out at the stars, you're going to get a quick understanding of what characteristics fit which moon. And you'd probably be better able to identify each fairly quickly.
Probably.
Over time. It'd be fun though. But it was fun to pull up the telescope and take a peek at it a couple times. And it's just in such a good spot right now because it's up all night long, and it's really bright. It's really, I think it's at one of its brightest positions or brightest points that it's going to be for us, and it's passing right now. So it's cool.
Well, it's really cool.
I'm not sure how that goes. I guess it does get dimmer and brighter as we get, close side and then far side from it. But I was wondering if it affects Jupiter the same way as like it does Mars. Like Mars right now is really bright. And how we were talking about, it's getting way brighter up and through the end of the month and the beginning of next month.
Yeah, I don't know how that is for you.
Yeah, well, Jupiter's a little bit different. It does get dimmer. It's very bright right now. There will be times that we see it where it'll look a good bit dimmer, but really often it's a pretty bright.
It is, yeah.
It's
a pretty easy one to spot.
Yeah, Saturn's the one that's a little bit more flexible. There are times where Saturn is really a significantly bright item in the sky, and then other times where it's really very dim. Same with Mars too. Mars can be just very nondescript, like a third magnitude item in the sky, just a little point of orange. And then like right now, it's almost as bright as Jupiter. It's like a 2.5, or coming up onto -2 magnitude object in the sky. So it's like almost as bright as Venus gets in the evening, or as Jupiter is up in the night sky right now. It's really, really quite bright. It's cool. It's cool to check out. But yeah, so shoot, I think there was other stuff about Jupiter too. So there's the full moon coming up. That's tonight.
Right.
It's going to be over towards Scorpio. And so if you stay up late enough, I guess around like 2 a.m. or so, it'd probably be coming up around here for us around 2 a.m. But tonight it'd be up a little sooner, the full moon at least. But you can look out, you can see the full moon, and then you can see Mars and Saturn out into Scorpio. And Mars is still making its trek, I guess, eastwardly into Scorpio. And then at the end of May, on like the 30th, it's going to push back out toward Libra, which is going to be real strange.
Yeah.
But it'd be cool. We should look at Mars at its real close pass. And then we should look at Saturn. We should see its rings too, because I guess right now it's in a good position to observe the rings. It'd be cool. I hear on Mars, when you look at it through a telescope, you can see the ice caps.
Oh, really?
Yeah. And I guess they look kind of gray or greenish. It's sort of an optical illusion with the reddish color. Our eyes kind of balance it or try and white balance it. And so this white color or gray color ends up looking kind of green to us. At the beginning, early on, they thought it was a seasonal change where Mars was a planet and it was going through its growing season at that time. And so there was like a field growing or like algae growing or something is what they had thought. Some kind of crop growing. The Martians growing a crop. Yeah.
Martian crops.
Yeah. That's what they were thinking it was. But it was really just this kind of gray, I guess frost or ice cap is something like that. But
that's cool. Yeah, that'd be really neat to observe.
It is cool. You can't see really quite a bit. I'm not sure what ours is going to show. Like we were talking about at the beginning.
It's not the best telescope, so
we'll be able to see.
We might not see that as
little planet. Hey, it's Mars.
Hey.
Well, we might be able to resolve something, but kind of like Jupiter. It might really appear sort of similar to that. Saturn's satisfying because you can really make out the ring. Yeah, and you're like, hey, whoa, that's not a little dot.
That'd be really cool to see.
Yeah, it would be cool, and it gets way more fun when you get a better telescope.
Yeah,
like we were talking about. The object of a telescope is to collect as much light as possible. So the wider that aperture gets, the more light you're going to be able to collect. Similar like to how we talk about photography, the wider the aperture gets, the more light is going to be let in a shorter amount of time. And so for our eye, what that allows us to do is as we get it past, let's say for like a reflector telescope, like a Dobsonian or a Newtonian telescope, if we get past a 6 or an 8-inch or up to a 10-inch barrel, then we're able to collect a lot of light and get a better resolution. And I've really seen some pretty impressive views of the planets. Like you can see a lot of banding in Jupiter, and you can see a pretty significant amount of the moon. It's really cool.
It is really cool. Yeah.
Or Saturn too. You can see more texture, or you can just kind of make out the ring in a better way. It doesn't look like kind of a fuzzy dot with a hat on it. It's like. It looks a little silly sometimes, but at other times it can be pretty fun. So yeah, I guess a full moon tonight, and then what else is there going on? I don't think there's going to be too much going on for the rest of the week. It sounded like it was going to be a little low. There were a few things going on. There's like a comet out in Fucus, but it was like a 6th or 7th magnitude. It'd be real difficult to see. It's one of those deep sky objects that we'll wait until we get that big telescope. Hey. Then we'll start comet hunting a little more. It'd be a good time.
It's a good plan.
I want to see a cool comet come by again. Like it's been years. They're rare.
A long time.
That's why they're cool. Is they happen like a handful of times in life. But I guess that's why Halley's Comet was always so cool, because it was predictable. It was on this kind of 87-year cycle. We're probably the people who really may not get to see it, because it's like it happened like just a couple years after we were born. So I think we have to wait around until.
I missed that.
Yeah, we have to wait around until like the 2080s.
Fingers crossed, but
2080s, man, what are we going to be doing then? It'd be crazy.
Looking out of our super giant telescope.
Super giant telescope.
Halley's Comet.
Yeah. So we'll have the biggest telescope by 2080. Be pretty cool. But yeah, I think that's just about everything that we have to talk about for this episode of the Night Sky Podcast. I want to say thank you very much, Marina, for joining me today. I want to say to anyone listening, I appreciate it very much. Leave us a comment, shoot us a message or something like that, or subscribe or rate the podcast. Anything like that kind of helps establish that it's actually a podcast, which would be cool to do. So if you could do that for us, that'd be awesome. I guess you guys can tune in next time. Thanks for subscribing. And on behalf of Marina Hanson, my name is Billy Newman, and thank you very much for listening to this episode of the Night Sky Podcast.